In the previous video, we talked about number systems, and we were talking about how to convert decimal to binary and binary to decimal. And one most important thing we talked about is that like the computers don't understand our number system, the decimal number system. They just understand zeros and ones. So there's a reason for that. And that is because of gates, actually. So gates is the way we kind of process the information we have. So we'll have to convert everything into zeros and ones. Okay. So logic gates are a circuit that delivers an output either as high or low depending on the state of the inputs, actually. Of the two inputs, but like there can be multiple inputs as well. But like in general, there are two inputs, A and B, and like there's an output. So what input you give and like what output you get decides like what kind of gate it is. And using these gates, you can develop a program, and that program is what will be used to achieve some useful thing. Again, like we'll not be doing some basic stuff, so we'll be understanding the basics of it, but the way the computers operate right now is like really in advanced level. So imagine like we have billions and billions of transistors inside like a small processor or like a microcontroller. So this is kind of the logic behind it. But again, we are thinking in a very large scale. But like this would be sufficient for you to understand those. But like we will straight away get there, like when we talk about microcontrollers while learning Arduino. But again, this is kind of the basic, the fundamentals that you will have to know to understand that. Okay, so here, the most important thing is, okay, yes, it understands zeros and ones. Like how do they understand zeros and ones? So that is by the voltage that we apply. So a voltage which is close to a 5 volt. It really depends on the system voltage, but like for now, let's assume 5 volts. So often the integrated circuits we use, ICs we use, they accept a 5 volt input or like say 3.3 volt input. So in Arduino, when we say high and low, we are saying like high is 5 volts, low is like something around 0 volts. So that's how we say zeros and ones. So that is how we apply 0 and 1 to these inputs and see what kind of output we get. So this is logic gate. So there are different types of gates. So the common gates that we are going to learn today are these: AND or XOR. And when you add a NOT gate is nothing but it's like a flip-flop. So it kind of flips the output. So when you add them to the basic gates, then you get NAND, NOR, and XNOR. So here are some here's something called the truth table, so which will indicate what kind of gate outputs you can expect when you feed different combinations of the input. So here black is 0. So when you apply 0, 0, what happens in the AND gate? So and NAND gate, OR gate, NOR gate, XNOR, and XOR and XNOR. So let's start with AND gate. So AND gate with the name indicates like only when you get both inputs high, that is like input A and B, when both A and B, that's why it's an AND gate. If you get A and B as high, that's when like this will be high. So here if you see both of them are turned off, so this is going to be turned off. So one is turned off, and that means again still it needs both to be turned on to be turned on. So here it is turned off, in this combination it is turned off, but like the only combination in which it is turned on will be when both of them are turned on. And NAND gate is a flip-flop, so it's an opposite of AND gate. So which means whenever this is turned off, this will be turned on, and when this is turned on, it will be turned off. So it's exactly the opposite. So that is AND and NAND. OR gate is either or. So at least one of the inputs have to be turned on to turn this on. So here nothing is turned on, so it's turned off. So here we have B turned on, so it's turned on. Here it's A is turned on, so it's turned on. Here both of them are turned on, so it is turned on. So it is exactly the opposite. XOR is quite different. So here it has to be opposite actually. So when both of them are in the same state, the output is off. So here both of them are off, so the output is off. Here both of them are on, and the output is on. The output is off. But when one is off and the other one is on, then the output will be on. So XNOR is exactly opposite to that. So this is called the truth table, and this is how the gates work. So we use these gates to create a logic and make it function like the way we want it actually. So that is logic gates. In the next video, we'll talk about multimeters and breadboards and like how to prototype and things like that. See you in the next video.